Path Geometry. From our Holt textbook, this is Algebra Lesson 9-9. Using the discriminant to determine the type of solutions and using the quadratic formula to solve quadratic equations. Our learning targets are to know what the discriminant is and be able to use it to determine the number and types of solutions. That will be our first learning target. Our second learning target will be to use the quadratic formula to solve quadratics. There are quadratics. So far, right now, we know how to solve them if they're factorable. But there are lots of quadratics out there that are not factorable, and when they're not, we have to use another method. We have a couple different methods, and the one we're going to be covering is the quadratic formula. Quadratic function. A quadratic function comes in the form y equals ax squared plus bx plus c, where a is the coefficient on x squared, b is the coefficient including its sign on x, and c is the constant. There is a quadratic formula, but I want to first talk about the value of the discriminant, which is part of the quadratic formula. Quadratic formula I'm not going to derive for you because we need to understand how to do completing the square first. You'll be learning that in Calc Path Algebra 2. The discriminant is b squared minus 2ac. If you take the coefficient on x with its sign and square it, subtract 2 times the coefficient on x squared times the constant, it will give you either a positive number, it'll either be greater than 0, or it'll be equal to 0, or it'll be less than 0, which means it's negative. If you do this and you get a positive number, then you have two real solutions. And if that number is a perfect square, then it will actually be a rational one that can be written as a over b, a rational solution. But if the positive number is not a perfect square, then it'll be an irrational solution. It'll have radicals like the square root of 2 involved in the answer. So we have two solutions. We can see that on the graph. If it intersects points, there's going to be two real solutions. They might not be factorable if it has radical answers. If it's perfect square, if the discriminant's perfect square, then there'll be fractions or whole numbers or integers. If it's equal to 0, then that means that there will only be one solution. It's called a double solution because if you have a quadratic and you factor it down, it may come from the same factor, like x minus 1 by x minus 1, which would give you x equals 1. There's two factors that lead to that. We actually call this multiplicity in Algebra 2 and in pre-calculus. But for right now, you just need to know that if your discriminant is 0, there will only be one real intersection point with the x-axis. If the discriminant is negative, then that means that there are no real solutions. There's two imaginary solutions. For now, we're going to say no real solutions, but it does mean that they're two imaginary because they involve a certain number set that we have not learned yet. But that means that there are no intersection points on the x-axis. The graph either falls completely above the x-axis, or if it's opening down completely below the x-axis. So we'll look at imaginary solutions later. For now, we're going to focus on positive, or two real solutions, one real solution, and no real solutions. So we're going to look at using the discriminant to determine the number and types of solutions. When you use the discriminant, or when you solve by quadratic formula, just like when we solve by factoring, we need to make sure the function is equal to 0. This function is equal to 0. So the value of a for this function is 3, the value of b is -2, and the value of c is 2. Following the formula for the discriminant, I'm going to do b squared minus 4 times a times c, or -2 squared minus 4 times 3 times 2. I can do this very quickly on my own, or I could, if I have technology, I can plug it in real quick. If you're plugging it in, make sure it's in parentheses, because if I do -2 squared, it'll be 2 squared and the opposite, which is -4. But -2 squared is 4. I have to be very careful. I don't want to do this because -2 squared is negative times it should be positive. So negative 2 squared minus 4 times 3 times 2 is negative 20. Our discriminant is negative 20, which means there are no real solutions, but there are two imaginary solutions. They're very important. Those other solutions are important even though they're not on the real number axis. But we're not getting to that today. Just focusing on being able to do this formula for now. In our next problem, it is equal to 0. So the value of A is 1, the value of B is 8, and the value of C is 16. So our discriminant for this problem, when I do B squared minus 4AC, I have 8 squared minus 4 times 1 times 16, which would be 64 minus 64, but let's plug it in anyhow. Minus 4 times 1 times 16 is in fact, whoops, I forgot to square that. Fine. Is in fact 0 because it's 64 minus 64. So our discriminant is 0, which means we have one real, and you can check the table above, when the discriminant is 0, we have one real solution. And I can actually solve this one, usually by factor. It would be by factor. It should be factorable. If I go to factor this one, I have x and 4, x plus 4 by x plus 4. So x equals negative 4. It's a double solution because it comes from two factors. Let's take a look at the next one. Please take a second to see if you can find the discriminant using the values of A, B, and C. So pause the video and see if you can find the discriminant. Value of A was 2, value of B was 11, value of C was 12. When you plug this in, we have B squared minus 4 times A times C, which is 25. So we do have two real solutions, and they're going to be rational solutions because it's a perfect square. So because it's positive, there's two real solutions. Because it's a perfect square, they're going to be rational, which means they'll be fractions, ratio rational. So we can actually factor this one if we want to. This one would be 2x and x. Factors of 12 could be 6. I'm thinking more along the lines of 3 and 4. 4 and 3 will work because that multiplies to 12. 3 and 8 is 11. So here, when I set this equal to 0, I'm going to subtract 3 and divide by 2. When I set this equal to 0, I'm just going to subtract 4. There are my two x-intercepts. If I were looking at the graph of this, those would be the x-intercepts. So this one and this one were factorable, just like we had learned about earlier in calc path geometry. But now we're going to learn that if it's not factorable, we can still solve it. So if it's not factorable, the next thing that you should go to, at least for now, until you learn other methods, the method of completing the square, is the quadratic formula. The quadratic formula is the following. Opposite of B, not negative, because if it was negative, it's going to become positive. So opposite of B over 2A plus or minus the square root of the discriminant. We already know the discriminant. B squared minus 4 times A times C over 2A. Now, some people like to sing the song Pop Goes the Weasel to help them remember this formula, to memorize it. So it goes like this. X equals the opposite of B plus or minus the square root of B squared minus 4 times A times C each over 2A. If you want, you can sing it yourself. You can rewind the video and listen to my horrible singing of it. But again, this is given the quadratic in the form when you have equal to 0, ax squared plus bx plus c. So our next task is to use this formula, even if it is factorable, because we just want to make sure we know how to use the formula. To use this formula to solve. But first, we need to know how many solutions and what type there are. And you're only going to use the quadratic formula right now to solve for any real solutions. Later this year, in Algebra 2 and pre-calculus, you will solve even if they're imaginary, you'll have to find them. So the very first thing, as I go find the discriminant, I look at this and realize it is not equal to 0, so I'm going to add 4 to both sides to get it equal to 0. Now that it is in the form I need, I can do the discriminant, b squared minus 4ac. B squared is 4. 4 squared minus 4 times 1 times 4 is 0, which means I have one real solution. Notice it says use the discriminant to determine the number and type of solution. I have one real, and when it's one real, it will be rational solution. So one real solution. That's the first part. Now I'm going to do the quadratic formula. But the good news is I've already done part of it right here. So all I have to do is the opposite of b, b is 4. The square root of 0, well, that's easy. That's 0 because the discriminant is 0. And each of these numbers has to go over 2 times a. The value of a is 1. So just 2 times 1, which is 2. Well, 0 over 2 is still 0. So I have plus or minus 0. I don't need to worry about it. It's just x equals negative 4 over 2 plus 0, or minus 0. So this is x equals negative 2 as our solution. If I plug that back in here, negative 2 squared is 4, plus negative 8. 4 plus negative 8 is negative 4, so I know I have the correct solution. In our next problem, the quadratic is already set equal to 0. So I can find the discriminant, because a is 1, b is negative 9, and c is 4. The discriminant b squared minus 4ac would be 81 minus 4 times 1 times 4, or 81 minus 16. You can also plug it into the calculator completely, and I get 65 for my discriminant. This is positive, which if you look back at the front means that there are two real solutions, but they are not rational, because this is not a perfect square. So they're going to be irrational, meaning that they cannot be written as a fraction, as a single fraction in terms of the fraction of integers. So I'm going to do the quadratic formula now. I already have part of it done. We have the discriminant, so we've got the square root of 65. The good news with the square root of 65 is no perfect square going to it. 5 goes in 13 times. 13 is prime, and so is 5. So we won't be able to break that down, unfortunately. Now I do the opposite of b. b is negative 9. So to do the opposite of b, I need positive 9. And these each have to go over 2 times a. a is 1. So and that is 1. This gives me two different answers. I don't see it in here. This gives me 9 halves, or 4.5, plus square root of 65 over 2. It also gives me 9 halves minus the square root of 65 over 2. If I were to graph this, I would find the x-intercept at roughly a decimal approximation of 8.53 and roughly a decimal approximation of 0.47. But the exact value is in radical form. Here's our last problem for the notes. This one is not in standard form, so I'm going to add 3 to both sides to get it equal to 0. Now that I have it in standard form and equal to 0, the value of a is 2, the value of b is negative 2, the value of c is 3. So a b squared minus 4ac, negative 2 squared is 4, minus 4 times 2 times 3 is negative 20. Well, there's our discriminant. Since it's negative, there are no real solutions. There's actually imaginary solutions. 2 imaginary solutions. solutions. And we will look at how to find those later this year, probably toward the end of the year. We're not going to really encounter many of those in our geometry problems. When we meet next in class, I'm going to ask you to try a few problems before we do some practice, just to make sure that we can all correctly find the discriminant and determine the type of solutions, and then plug that into the quadratic formula to solve. Were our learning targets for this lesson. This ends the video notes. Have a great day.